So we handled circles last week. Okay? And then we did parabolas last week. And then this week we handled ellipses and hyperbolas. Okay? So you've got the 4 different kinds of conic sections that there are. Okay? Today and Monday, what we're going to do is we are going to change the forms of conic sections. So instead of saying, this is a parabola, this is an ellipse, this is a hyperbola, this is a circle, we are just going to give you an equation. And we're going to ask you to, 1, figure out what it is, and then 2, graph it and give all of the points and all of the lines and all of the things that we want with each one. Okay? So, to recap, the general form of all of the conics are, I think I thought I could get it all in one. Apparently I need to move some stuff up a little bit. Now we can get it all in one. Okay? So there is the 4 different conics, the 4 different general forms. Okay? Meaning, I'm going to give you something along the lines of x squared plus y squared minus 2x plus 4y minus 1 equals 0. And I'm going to ask you to, 1, identify what kind of conic it is. 2, put it in that conic's general form. 3, give me all the key points or key parts to it, and 4, graph it. Okay? So we can do all of that based off of just an equation now. Okay? So you have all of those at some point in time. If not, look back in your notes to get the rest of them. Okay? So, how do we differentiate between the 4 conics? Okay? Well, let's take the easy one first. Parabolas. Parabolas are the easy one to determine which kind of conic it is because there's only one variable that's squared. In a parabola, you either have x squared and then a linear y, or you have a y squared and a linear x. Okay? That's the easy one. Parabolas. Okay? Only one squared term. So as you're looking at your equation, if you only see one squared, that's a parabola. Okay? The second easy one is actually the hyperbola. Because the hyperbola is the only one where you are subtracting a squared term. Okay? So a parabola has one squared term. A hyperbola has a subtracting of a squared term. Okay? The not so easy ones are circles and ellipses because they're so similar. Okay? Both of them have 2 squared terms. Both of them are adding the squared terms together. The difference is that an ellipse, the coefficients on the squared terms are different. Okay? If the coefficients are the same on the squared terms, it's a circle. If the coefficients are different, it's an ellipse. Okay? So to recap, parabolas, only one squared term. Hyperbolas, subtract one of the squared terms. Circles and ellipses have different coefficients on the squared terms. Okay? want you to just classify the conics. This is going to be 4 examples of the problems that you're going to see. Okay? So this would be a problem now that I would give you. I would say 6x squared minus 2y squared plus 24x plus 2y minus 1 equals 0. Okay? And I'm going to say classify it. Then I'm going to say put it in its standard form. Then I'm going to say graph it and identify all the key parts to it. Okay? So looking at letter A here, do I have 1 or 2 squared terms? 2. So that eliminates one of the 4. Which one is eliminated? Parabola. This is not a parabola. Okay? Second, am I adding the squared terms or am I subtracting the squared terms? Subtracting, so that makes this one a hyperbola. Because of that subtraction sign right there. Okay? B. What do you think B is? How many squared terms? 2, so that means it's not a parabola. Are we subtracting the squared terms? No, that means it's not a hyperbola. So now I got it narrowed down to circle and ellipse. Okay? Are the coefficients the same or are they different? Different. So different coefficients are ellipses. So this is an ellipse. Because of that 4 and that addition sign. C. What do you think C is? Why parabola? Only 1 squared term. D. Why circle? Bingo. There's 2 squared terms. They're being added. And the coefficients are the same. So that's a circle. Okay? I didn't think there was anything else down there. All right. So, let's get into writing those equations. We had a couple of problems like this a while ago. Okay? So, a circle with a center at 3, -2 and a radius of 4. So, the circle formula is x minus h quantity squared plus y minus k quantity squared equals r squared. Right? Okay. What's h? 3. What's k? -2. What's r? 4. So the equation here should be x minus 3 quantity squared plus y minus -2 quantity squared equals 4 squared, which is 16. Yes? Okay. There's 2 formulas for a parabola, right? Depending upon which way it opens. So before we even start, we should figure out which way this opens. If I have a vertex at -2, -4. That means my vertex would be down there. And a focus at 4, -4. It looks like that, correct? Okay. Which way does it open? It opens to the right. Right opening parabolas have the form of y minus k, quantity squared, equals positive 4p times x minus h. Correct? Do I know what h is? What is it? -2. Do I know what k is? Okay? -4. Do I know what p is? What? Because there's a distance here of 6. So, and that is my p. Okay. So this equation is going to be y minus -4, quantity squared, equals 4 times 6 is 24 times x minus -2. Okay. What I would like you to do now is I would like you to find me the equation of the ellipse. Oops, and I'll move the other one up there too. So I need that, and then I need, oh yeah, I gotta go up here, and I got to, there, now they're both on there. So find me those two equations. All right, walk me through finding the equation of an ellipse. We did it Monday and Tuesday.
It's more of a question.
Okay.
So like the vertices are like the points, so wouldn't you just find the middle of -1 and 7 for like the center?
Okay. So what you're saying is I've got a vertex here and a vertex here, right?
Yeah.
So the midpoint of those points would be the center.
Yeah, so I got 3, 5.
Okay, I would agree with that. Do we all agree that the center is at 3, 5?
Yes.
Okay, I would agree with that.
Yeah, that's his.
Okay. Then what? So we can find A, right? Because I got foci there and foci there, right? But this distance is A, right? And that's going to be 4. Okay. What else do I have? What? What else do I have?
You have C, but
I have
don't
C,
know what it is.
right? Because C is the distance to the foci. Which is what? 2. Okay, so from my ellipses, how do I find that C value? What's the formula that I use? No.
Oh.
What? A squared minus B squared. Okay, so C is 2, which means then C squared is 4. A is 4, which means A squared is 16. So that's going to be what? 12 for B squared.
the one with the absolute value?
This one. That's this one. But we're okay with it. Mm-hmm. Really, that's only in cases where when it's the ellipse is tipped on it, so it's a vertically stretched out ellipse. Okay. Since this one was horizontal, we were okay with it. So that tells me that so I should write down what my formula is. X minus h quantity squared all over a squared plus y minus k quantity squared all over b squared is going to equal 1. So,
Can I say it for you?
go ahead.
In parentheses, x minus 3 all over 16.
Quantity squared
Yep.
all over 16.
Plus, in parentheses, y minus 5 quantity squared
Atta girl.
all over 12 equals 1. Don't forget about it.
Don't forget about that equals 1. Exactly. Don't pull in algebra 3 and forget about it. Okay? Again, these are the kinds of things that how to do these problems and what you need to do and these formulas, that's what needs to go on that note sheet for Wednesday. Okay? So, let's work hyperbola now.
Hyperbolas.
Hyperbolas. So I've got a vertex here and here. Oops, this one would be down a little bit farther. Nope. Walk me through this one. Focus back in here. Focus back in.
No.
Okay? So I got vertices there. What does that mean? The middle. So where is the middle of those 2 points? 7 comma negative 1. Okay. What else am I given here? We have what? What's B? B is 2. So you'd have to cut it out and paste it onto your. Yeah. Okay. What's C? Five. Okay. What is the relationship here? No, it's not, because they're different. This one's a squared plus b squared equals c squared. Even though in the last one it was minus? Okay. Yes. Now, if you think about it one way that I remember it, it's opposite of what the sign is in the equation. Ellipses, the sign in between the squared terms is positive. In the c value, it's negative. In hyperbolas, it's subtracting of the squared terms, but it's an adding to get the c values.
Wait,
Yeah.
so like you could remember it by like a squared plus b squared equals c squared. Isn't that how you find the hypotenuse?
Yeah. Yep, exactly. There you go. All right. So 5 squared is 25. A squared is a squared. B squared is 4. So that gives me 21 is a squared. This is an up-down or a vertical hyperbola, so that's going to be a y minus k quantity squared all over b squared minus x minus h quantity squared all over a squared equals 1 equation. So that's going to be y minus negative 1 all over 4 minus x minus 7 quantity squared all over 21 equals 1 equation. Okay? In order to take these kinds of equations right here and make them into standard form, we have to think back to completing the square. You all learned completing the square at some point in time in Algebra 2. Okay? It's a way to solve or factor something where we create a perfect squared term. Okay? Now, there's a couple of different paths, if you will, to get about doing the same thing. One philosophy is you keep everything on one side. One philosophy is you only keep what you're perfect squaring on the one side and you move everything to the other side. Okay? So there's two different paths to go down here. I am of the form of keep what you're squaring on one side and move everything else to the other side. So it really is a personal preference kind of a thing. But what you need to do is you definitely need to space out your equation. So in this particular case, I would put x squared minus 6x equals negative 11, and I would have this gap after the 6x term. Okay? If you're on the same side type of thing, then yours would look like that. You would still put the space in the exact same spot. Okay? But again, that's not me. That's me. Okay? Then, once you have that done, you're going to factor the variable part so that the coefficient on the squared term is positive 1. That's already done for us here. If it wasn't, we would put the entire left side in a set of parentheses, and we would factor that, whatever that coefficient is, out. And then we'd go from there. Okay? So b is going to be your non-squared coefficient. Okay? So in this case, b is negative 6. What I need to find then is I need to find b over 2, and I need to find b over 2 squared. So negative 6 is b. What's negative 6 divided by 2? Negative 3. And what's negative 3 squared? 9. Now, those are important because the 9 is going to fill the space. Actually, here, let me put it as what it actually is. The b over 2 quantity squared is going to fill space.
Does it matter that you have to write this in there?
Yes, and you'll see why in a minute. Okay? But now I've created an imbalance in my equation. I've added 9 to the right side. So what do I have to do, Olivia, to get back into order?
Me?
You're the only Olivia in the room.
Sorry, sometimes Olivia is in here.
Mhm.
Yeah, I wasn't paying attention.
I know you weren't. That's why I called on you. Okay? All right? So if I have to get the, so if I added 9 to the left side, what do I have to do to get it back into order? I got to add 9 to the right side. Now I'm back in balance. Okay? Okay? So we have to remember to balance our equation. Then, now, this next step is down here. We're going to factor the left side. So if I factor this side, that's going to become x minus 3 quantity squared. Which, Natasha, back to your question, why does the negative sign matter? Because this is going to be this number right here, the b over 2. This number is going to be b over 2. Okay? And that's going to equal, in this case, negative 2.
So x minus 3 squared, that's the whole thing of x squared minus 6 squared plus 9.
Mm-hmm. Yep, if you would multiply that out, you'd get x squared minus 6x plus 9. Okay. Now, if we were solving, we would take the square root of both sides and so on and so forth. That's really where we're going to stop it here, because we don't want to solve for x or solve for y in our equations. We want to just get it into this, and in this case it would be x minus h form. Okay? So that's why we kind of want to do it. If we were going on, we would square root both sides, and so then this side would become x minus 3, and that would equal plus or minus the square root of negative 2. And then we would go on and we'd solve this. So we would go x minus, or x equals 3 plus or minus I times the square root of 2 would be the solutions to it. But again, we are not solving in this stuff. We are just simplifying.
Okay.
Okay?